Okay, when you see power of 6, it's almost always going to involve the difference or sum of cubes. So this can be thought of as cosine squared x to the power of 3 sine squared x to the power of 3. This is currently in this form. If a was equal to the cosine of squared and b was equal to the sine of squared, it's currently in this form. Okay, so this can be factored into this, and then square this, so you get cosine 4x plus cosine squared x, sine squared x, and square that. This here is the expanded form of cosine of 2x, so we get that. How do we get 1? Okay, we don't have 1 here. So note that this here can be thought of as cosine squared of a squared. Okay, and if I actually had 2 cosine squared x, sine squared x, and this is sine squared x of a squared, this here is a perfect square. It's gonna become cosine squared x plus sine squared x all squared. If you expand this, we'll get this exactly. But that's not what we have. We don't have this. We do have these two, but this here, right, is 1 more than this. So what we have to do is subtract right after here this. Then what we have in this bracket is actually the exact same thing as what we have in here. So these 3 is equal to that, and you get a minus of this. That's 1. Okay, now we want a double angle. So this is the same as, so change the order of the sine and cosine. So sine appears first. Isn't it the same as this? Okay, it's exactly the same as that. And the product of sine and cosine is exactly half of sine of 2x. Now you just square that in, and you get 1 over 4 sine 2x squared. We're done.